So welcome to Lecture 8, Graphical User Interfaces. So with this lecture, we're not going to finish the theory within a single period. So we will do some of the theory now, we'll look at some code, and then jump back to the theory, look at some code as we go through this. So with graphical user interfaces, we're going to start working with user applications, something that an end user can use that is graphical in nature. So far, we've been doing command prompt types of applications, console applications, where you have to have a command prompt to work with. When you have information going to your program, we sort of looked at looking at system in, system out, how we access it like that. And if need be, we have command line arguments as well. We didn't really use it too much when we were running our different practicals, especially the practicals that were given to you. We saw a little bit about that in the lectures, but it wasn't the main method of accessing information from the user. And the reason for that is because we're going to start looking at graphical user interfaces. We're going to start working with the user, interacting with buttons, interacting with menus, interacting with the text area. All of these different terms, you're going to see what they actually mean and what type of information we can get from the user. So before we get to that, we need to discuss graphical user interface frameworks. Now, we're going to discuss frameworks in the sense of Java itself. We're not going to look at other languages, other operating systems, all of those type of things. We're going to look specifically at Java because that's what we're teaching you in Computer Science 2A, to teach you all the different concepts we're using Java. So that's what we're going to focus on. So with GUI applications, I'm going to say GUI because it says it's faster than saying graphical user interface every single time. It's working with something that is graphical. That's the major difference, working with something that is graphical. Even when you're working on something like a cell phone, you're working with a graphical interface, something that you can see. If you're working with a phone, tablet, you are touching something that interacts with that device. Your touch screen on your phone or your tablet interacts with the device. If you're working on a laptop or a desktop, you usually have a pointing device, some sort of cursor, and that thing will move around the screen and you can click on different things. Depending on what type of click you use, left click or right click, it means different things. So we have to write applications that process that information from the user and do things accordingly. Now, when Java first came out, there was a lot of things which were not known how to do. And some of those things were, how do we make sure that we provide the same interface whether you're running on a different operating system? Because remember, Java is platform independent. How is it platform independent? We write Java source code, it's compiled onto bytecode. Bytecode, it gets interpreted on the Java virtual machine. So the thing that has to be specific to an operating system is the Java virtual machine. The thing that doesn't need to be specific is the code we write. However, every operating system runs things differently. Most of you have experience with Windows operating system. If you're working on a Unix-based system, you're working on Linux, most of the time the first sort of operating system that you might be working with in that space will be Ubuntu, something that is becoming very popular over the last decade or so. It has a very different user interface, whether it's a graphical user interface or command line interface. Both of them are very different than Windows. Same can be said for working with Mac, working with Apple products. It's a different interface as well. Different places where things are, different look and feel of the things that are available. So Java has to manage all of those different capabilities. And the first way it tried to work with a unified user experience, a unified GUI, is by something known as AWT, the Abstract Windowing Toolkit. So this was the first iteration of Java trying to build graphical user interfaces. So the problems, what they tried to do was try to make everything map directly to the operating system. If there's a button, the button would map directly to an operating system button. So a button would be directly a Windows button, a button would be directly a Unix button, or a Mac OS button. However, doing it through that, we had to rely on the operating system the whole time. So Java had to ask the operating system to create a window, create a button, create all of those different things. And that made it very slow because these components were known as heavyweight components because we had to rely on the operating system to do all the lifting for us. So it works with many different operating systems, but if we try to create new components, something that wasn't available in the operating system, it was very difficult to do. So the first iteration, people who Java looked back and said, okay, let's try and make this better. Then came around the next GUI framework, which is called Swing. And Swing is something that is still being used nowadays, but people have been moving over to the latest framework, which is what we'll see on the next slide, which is JavaFX. So Swing kind of replaced AWT. It didn't replace it completely. They still have things that we use from AWT when you write Swing code, but it gave us a way to do things a little bit better. One of the key things here is that we don't rely on the operating system to do things for us. We try and do things in Java code instead. Then we come to JavaFX, and this is where we're going to be spending our time trying to work with graphical user interfaces. So with JavaFX, the people behind Java saw that as things were moving forward, desktop computers weren't the future. They weren't going to be the only thing that people used. So they said, okay, we're going to try and adapt to the situation, and they targeted rich internet applications. Rich internet applications in the sense that it might be web-based, so you might work on it in a web browser. It might be web-based in the sense that you run it as a desktop application, but it has web-like features, or it could be on a mobile device that also has web-like features. It also had extra support for things like multi-touch support, so having a touchscreen and being able to touch it with multiple fingers, etc. On tablets and smartphones, it has built-in 2D and 3D support, animation support, all these nice features that wasn't available in the previous frameworks. So things like Swing, things like AWT did not have 2D and 3D rendering built in, or very efficient 2D and 3D rendering built in. You had to rely on someone else writing that code and then using the jar files that you provide to provide the functionality in your system. So JavaFX became the point of trying to make sure that Java isn't stuck in the past. Java doesn't get stuck with just Swing components that only work on desktop devices. There was something called applets that was available in Swing, and JApplets that was available in, applets available in AWT, JApplets available in Swing, but they weren't very good because of security issues. A long time ago, most of the time you needed to update Java or a browser was because there was a security vulnerability in Java that needed to be patched. Then the vulnerabilities went into something called Flash that needed to be patched. Nowadays, you have browsers updating every other week because of those security vulnerabilities. Question? Okay, so the question was, if you have a user interface written in Swing, can you migrate it to JavaFX? Yes, by hand. You can write new code that matches the old functionality. There's nothing going to be automatic. Because with Swing and AWT, they worked with each other. You could write some code in AWT, you could write some code in Swing. But when we get to JavaFX, it's a completely new system, completely separate from anything before. So there's nothing common in terms of the classes that are available. Functionality might be similar, but you have to write new code for that anyway. Okay, so two questions. When was JavaFX introduced? JavaFX 1.0 started with Java version 8. It was a separate thing, and then it sort of became bundled halfway through the life cycle of Java 8, and then it was unbundled again. At the moment, at this point in time, anything from version 9 onwards, JavaFX is a separate download, separate maintenance, separate completely from the Java JDK. That's why you need to have the JavaFX JDK, JavaFX DK separate. Then the second question, sorry, just repeat the question again. So Java is the whole ecosystem. JavaFX is just looking at graphical interface stuff. It's not going to provide you with language features. It's more about graphical user interface features. Okay, so in order to understand JavaFX properly, we need to look at concepts in JavaFX. Some of these will make sense. Some of them you might not have experience with the real life counterpart, might not make as much sense, especially in this day and age with everything being online. So JavaFX uses the metaphor of a stage. So a stage would be something like this lecture hall, where you have a section where you have things that will happen. That will be the stage where things occur. If you ever went to live theater, they usually have that, or maybe plays at high school, something along those lines. You have a single stage, but you need to show different things. And they would bring on props of trees or whatever, do a play, do a scene, and then take those things off, bring new things on, and play out a different scene. And that's essentially what JavaFX tries to do. You have a stage, everything happens on that stage, and you just swap scenes out in that specific stage. Honestly, on a scene, what we put on the scene is something called a node. And with a node, it could be a layout node. We'll talk about what those are. It could be a control node. We'll talk about what they are as well. And basically, those things will allow us to create user interfaces. So I'm not going to read all of that to you. I'm just going to show you what we actually have in terms of the sort of metaphor that we're working with. So you have your UI components, your controls, all of those things that are nodes, and nodes are put into the scene graph, and the scene graph is part of a scene. Now, a scene graph, if you've done anything with the Cartesian plane, do you remember that thing, Cartesian plane? X and Y coordinates? We have that still available here. And that scene graph basically says, draw this button at this X and Y position, draw this thing at this X and Y position. That's still going to happen here. And the scene graph basically describes where things are relative to each other. All of that goes into a scene. We can do some extra things with the scene, we'll see later. And all of that things in the scene get put onto the stage. Now, the nice thing about this is we have one stage, but we can swap out scenes if need be. We're not going to get too in-depth with swapping out scenes. Most of the time, we'll be working with one scene because we don't have a very complex application, but that functionality is available for us to use. Now, with the classes that are available, there are a couple of other classes which wasn't mentioned earlier. One of those is application. Application is the entry point into a graphical user interface in JavaFX. It's sort of the class that has the main. Now, we're going to still keep with our baseline of having the main method, our convention of having the main method inside a class called main, and that will be the thing that will launch our JavaFX application. Another class you'll see there is something called pane, and this is a class that is used to handle layout. Layout basically says where does different controls go, and we'll look at how that works when we get to the examples for different layout nodes. So looking at the basics of what we need in terms of trying to launch a JavaFX application. So one thing that's missing here is the imports. But what you can see here is we have main extends application. That's the first big thing that you see. We have main extending application. And this allows us to call this method called launch. We can pass command line arguments that we get from the command line to our application through that launch method. And that will call all the necessary things in order to create a window that will pop up and display something inside of there. And the way we do that is we need to have a start which gives us a stage to work with. So we cannot create instances of stage. We have to be provided with a starting stage or the primary stage, and then we work from there. So with the stage, we can set a specific scene. Now, that scene depends on what we want to do. If we want to show a button to the user, we'll put that onto the scene and then set that as the primary scene for that stage. And then once everything is ready, once we're ready to show the window, we call show. And that will actually display the window with whatever contents we need. So when we're working with JavaFX, we're going to look at many different classes. Now, I'm not going to be able to go through every single one. As usual, the right place to look for this information is JavaDoc. However, because this is JavaFX and JavaFX is not the same as the JDK, you will have to look at the JavaDoc for the JavaFX and not the JDK. So there you can see the first class is application, and you can see it's in the package JavaFX. Instead of being Java, Java is all the JDK stuff. All the packages here are going to be JavaFX. Previously, things like AWT and Swing were part of Java. But now, JavaFX is separate. That's why we're in the separate packages of JavaFX. So application, that's going to have the application that we had main extend. Then we have stage, that will be used for working with scenes. Then we have something called a file chooser. So that's an interesting little window that you can choose a file. You can ask the user to choose a file. When you're on Eve and you need to upload something, usually a submission for a practical, you click the button and the window pops up asking you to choose a file. That is a file chooser dialog. We will see examples of that. We'll see different types of dialogues, a save dialog or an open dialog, and they're going to do different things. Then we have JavaFX scene package, and the scene subpackage has obviously the scene class, which has all the things that handle the scene graph. Then we have control, which has all our control things, which are going to be nodes that will provide us with some way to control the application, buttons, labels, etc. Layout, going to tell us where things are or how to lay things out, and you'll see there's next section we'll talk about that in more detail. Then canvas and graphics context with canvas. This is where we do manual drawing, and this is where we're going to start working with design patterns in more detail. So that will come up a bit later. And then you also see paint color. We saw paint color in one of our previous advanced object orientation lectures, where we saw that geometric object had JavaFX paint color. And that basically gives us a color to work with. There's different defined colors, so things like red, blue, green, magenta, yellow, cyan. All of those colors are defined inside of that color class as static variables, so we can use them very easily. But we can create our own colors by manually creating a color in code. But we'll talk about that when we get to low-level rendering. So with nodes, we cannot just have them by themselves, just floating around in free space. We need to put them into a scene graph. So with the scene graph, we can basically say where things are by using different layout nodes. So layout nodes give a general idea of where different controls should go. It would be very difficult to write a GUI application if we had to tell a button had to go exactly at 100, 100, X and Y. Then the label needs to go next to that at 100, 150. And the next thing has to go at 200, 150. Writing a GUI interface like that is very tedious. And if someone changes the size, all our measurements might be wrong. So we need some way to automatically adjust for certain use cases the layout of our nodes. Maybe we want things as the window gets bigger to stretch, as the window gets smaller to squeeze in. Maybe we want things to stick on a specific side, so either stick on the left and right. Even if the window gets big and smaller, those side panels don't get bigger or smaller. Maybe we want to have a toolbar at the bottom or status bar at the bottom, toolbar on top. All of those different layouts can be accomplished with different layout nodes. So we will be going through the layout nodes with actual live examples, so it's easier to see how these things work. But they are here just for completion's sake. So here's something called a flow plane. And a flow plane, what that tries to do is put components one after the other. So I should say nodes, put nodes one after the other. So with what we have here, you can see we have a label. That's the first thing we see there. That's going to be a label. That's just text which the user cannot select, but indicates what is the next thing going to be. And the next thing is a text area where the user can click and type some text. Usually a text area is text field, sorry. Text field is usually just one piece of information. It wouldn't be something like an address. Usually an address is a very long piece of information. That's when you use a text area. A text field usually is just one piece of information. Then we have, again, title, and then another text field, last name, another text field. And you could have more and more things, depending on the application you are writing. Now, with a flow pane, what happens is when the window changes in size, it tries to adjust everything to flow from left to right. And if you look at the window, the first label is on the left, and then as we move right, the next thing goes, the next thing goes. If we change the size of the window and we make it smaller, it will wrap to the next line, and we continue. So here you can see first name still in the same place. The text field is still there. There's another label, another text field. But if you look at the last label and text field, they went to the next line because there's not enough space in our window. So as the window gets smaller, we can tell the flow plane tells it to move to the next line. Now this doesn't give us always good results. We can run into the situation where you can see for the first name and the text field, everything looks fine. But then after that, we have a label and the text field is on the next line. So now is this middle text field, is that the title or is that the last name? Well, because we saw the previous stuff, you know which one's which. But if someone who isn't proficient in computers looks at this, they might wrongly assume that this text field is the last name because that's the label that's closest to it. So I can't teach you good graphic design, but I can tell you that's bad. So when you design your graphical user interfaces, You have to think about where things go. Now, that uh, field of study, it's called user experience. That can be a whole module just by itself. So that's something that you can look at trying to do. What we're going to do in the module is say that it should be clear what you're trying to do when you present something to the user. If you're doing a situation like this, try and avoid either have it like this or make it wrap two lines like that. We can do this by working with multiple layout nodes, and we'll see that in just a moment. So that's flow plane. Now we have grid pane, and grid pane basically arranges things in a grid. So here, it's the same set of nodes, same set of controls that we had before. Label, text field, label, text field, label, text field. But now what happens is we specified for this grid pane, it's going to be 2 columns, and then the rows will be however many things they are. We could specify exactly 3 rows, and if you put more, then we run into problems. But for this, we're going to say there's going to be 2 columns, and no matter how big or small we make this window, there will always be all the labels in the first column, all the text fields in the second column. So that's what a grid pane does. You could use this for other things. If you're writing a calculator application, usually on a calculator you have all the digits next to each other, usually 3 by 3 and then a 0 at the bottom somewhere. You could have a grid pane that could do something like that. Then we have something called border pane, and border pane has different sections. You have the top section, bottom section, left section, right section, and the center section. What border pane does nice is that whatever's on the top section, no matter how big or small you resize the window, top will always be at the top. Left will always be on the left, right will always be on the right, and center will always be in the center. So this is a nice overview of how to place things, and you could put other controls inside of there and make sure that they stick to a certain side of your pane. Then we have H box and V box. H box for a horizontal box, V box for a vertical box, and that basically stacks things either horizontally or vertically. Doesn't matter how big or small you make it, they will always be horizontal or always be vertical. So here you have, again, the same thing that we had before, label text field, but no matter how big or small you make that window, it will always be in that order. If you make it too small, then the text won't be readable, but that's what happens when you use something like an H box or a V box. And in this last example that we're going to have a look at here, you can see there's 2 layouts being used in conjunction with a third that manages the 2. So here we have a H box, so it's going to lay out things horizontally. And our first child in our H box is this grid pane here, and then the second child is going to be the border pane here. So inside our H box, we put 2 controls. Those controls are, 2 nodes. Those 2 nodes are more layouts, one being a grid pane, one being a border pane, and they behave exactly the same as if they were part of the whole window, except now they are smaller piece. So as you resize this, these 2 will try and share H boxes. The children of H box will try and share the space, and then individually, the border pane will try and manage its children inside of that space. It will manage whatever space it has. It will try and arrange everything inside of it. So this is just one example of combining different nodes together to get a different type of layout. You might need to do more than just one level. This is only 2 levels. You have H box, and then the next level you have either the grid pane or the border pane. You might have more levels, you might have 3 or 4 levels, and that will give you a nice user interface to work with. Okay, so what I want to do now is have a look again at applications which I have been using so far. So one of them is a PDF viewer, not Adobe. You can use Adobe if you want to, but this is something that is open source and free. I prefer that over having to pay money to someone for something that should be open source and free. So here you can see this application has a title at the top. That's that little purple section here that indicates this is going to be the title and shows you an icon and usually the name of the window. Then we have a menu bar. So menu bar used to be something that you could only put in a certain section, and then they changed it to be a bit more general. But a menu bar basically gives us access to different menus with different menu items. And below that we have a toolbar. And if I resize this window, you can see that the toolbar and the menu bar stay at the top. No matter how big or small I make this window, they usually stay at the top. Now this does have a minimum size. You can see I can't make it any smaller, and you can enforce that kind of things inside of your application as well. Now usually in most operating systems, you usually have 3 buttons that do certain things. So here we have, for Windows at least, we have minimize to taskbar, so that will go and minimize it down to the bottom here. Then we have another button that will maximize, so change it between a small window and a full screen window. And then the last one, that is your close. You click on that, it will close the specific application. Now, other operating systems don't use icons. They might use colors. And they might not be on the right-hand side. They might be on the left-hand side. So again, different operating systems do things a bit differently, but they usually have similar features in terms of what they have overall. So here, what we can sort of try and figure out is we have content in the middle. That's what you see. That's the slides that are being shown. And on top of the content, we have a toolbar that doesn't change away from the top. So that could be a border pane where we have our toolbar in the top and the content in the center. As you stretch, the center will get bigger and smaller, but the toolbar will stay always on top. Whether you make it bigger and smaller, the toolbar is always on top. If we look at something like Eclipse, now Eclipse is actually written in Swing. So this whole thing written in Swing with many custom components, because Swing doesn't give you all of these different features, but over the years it has been built up to have a very wide array of different types of controls that are available. But with this, we have similar things. We have similar layouts. We have, again, the title at the top, window title, title bar. We have the menu bar with menu items. And with menu items, you can have submenus as well. Then we have a toolbar, same like we had before. Then we have, this is known as breadcrumbs. It tells you where in a specific location you are. So if I open, for example, that, you can see it goes to a different location. So it gives you a trail of where you are currently. This is very useful when you're working with multiple files that might be the same name but in different locations. Good way to keep track of that information. And if we look at what we have here, we have sort of a left-hand side, a right-hand side, and a bottom. Not exactly like that, because if you look at anything inside of Eclipse, at least, you can put things in different locations. So here, for example, here is the console window, and I could put the console window side by side with another window. Or I could put the console window at the bottom of my code window, and that will split things up and move things around. So this is a bit more of an advanced layout, but you can see that concept of having different sides that you can attach to. And if you make things bigger or smaller, they stretch depending on what they have. So there at the top, for example, looking at the icons that you have here, if there's enough space available, They're next to each other, but as soon as there's not enough space, they wrap and move down. So that's a flow pane type of layout, but instead of going left to right, it's going right to left because it's sticking on the right-hand side. Okay. So usually you can put things back how you want it by dragging different things around. Another thing that we can have a look at here is at the bottom here we have something known as a status bar, and that usually gives you some information about the thing that you're working in. So in this case here, I think I haven't customized this Eclipse install yet, but one of the things you can clearly see here is some sort of memory management thing. This is looking at the memory your application is taking up using the Java virtual machine. And because the garbage collector comes whenever it wants to, there's a button that you can click and ask the garbage collector to come now, and sometimes that will reduce the memory that you are using. So if you have Eclipse open for a very long time and your computer is starting to run a bit slow, or Eclipse is running a bit slow, clicking the button might help, but clicking that button too much can also cause problems. So just be wary about that. But that gives you some information about what can happen with the application. If you open up different applications, if you open up things like Word, if you open up things like Notepad, so let me just open up Notepad. Uh-oh. Okay. Seems like my Notepad broke. That's fine. But usually if you open up things like Notepad, it gives you indication of which column, which row you're working on, what file is open, all of these different types of information that will be useful to the current learning application. So for example here, when I clicked inside of the code section, you can see here it gives me some information about what's happening in the file. So if I go here, for example, line 102, column 3, that's where I'm currently at in that specific file. And that's nice to have that information available so you can see what's happening overall. So we're not going to do something as complex as this. We're not going to create an application as complex as a full-blown IDE. You can if you want to, but what we will be doing is looking at how can we build a simple application, maybe something that when you click File, Open, it will show the dialog and you can choose something specific that the user can open. We can choose a file that the user might want to read. We can choose a location where the user might want to save. So all of those things we're going to have a look at in tomorrow's tutorial. We're going to take the education system that we're working on in the tutorial series. So far, we've just been working with the files in the data folder. We just read them, and then information gets displayed on console. Not very user-friendly. If someone is not proficient in using a computer, they won't know anything about a command prompt. They won't know anything about command line. Even though you wrote a lot of programs last year in Computer Science 1P, asking for options on the menu, press A, B, or 1, 2, etc. for those type of things. Nowadays, most people work with graphical user interfaces, so you have to have a way for that person to access information through a graphical user interface. So that's what we're going to do. We're going to see buttons you can click. We're going to work with menus and menu items. So we're actually going to skip the low-level rendering stuff, and we'll go straight on to working with GUIs. So we will talk a little bit about the theory about this, because we need that when we start working with GUI interfaces inside of the tutorial. But then we'll go into actually writing the code for trying to click a button and do something with it. Okay, so I'm going to end the session there. If you have any questions, I'll be at the front for a few minutes. Otherwise, I will see you tomorrow for the tutorial. Just give me 1 second. I'm just checking Blackboard. Okay. Oh, so yes. So those of you who are still here and those of you who are still on Blackboard, Practical 3 has been uploaded if you haven't seen it already.